But to really be successful at understanding all that systems thinking, what that return on investment might be, and so on, what system it takes apart on, you do need to be able to ultimately explain things simply, or learn it to a point where you can explain things simply so that you can then tie it back into the bigger picture, right? So you kind of go in depth in your learning, so then you're able to kind of almost go back up the ladder or whatever metaphorical staircase to then be able to see how it fits in that environment.
Welcome, everyone, to the Pample Pod. This is Jonathan, and I'm joined here by my lovely co-hosts.
Hi, this is Eugene.
And this is Michael.
Okay, and for our first segment, we're going to jump into the big question, where we discuss a difficult conceptual question. The topic that we're going to be revolving around today is the idea of what it means to stay on the forefront of your field and keep up with new emerging technologies, specifically in engineering. So, with this category, the first question I'd like to pose to you is, how do you stay informed about emerging technologies and new technical problems in the field?
Yeah, no, that's a good one. I don't know if you wanted to jump in on that, but I kind of went in there already. I feel like if I interpret your question as one of keeping pace, at least, right now as we kind of ease into this discussion, staying on top of trends, I feel like I kind of like to use I think some call it like a T approach, essentially very broadcasting across technologies, just kind of looking at a little bit of everything, especially things outside of my field. I think it's kind of interesting to get that, outside perspective. And then sort of that'd be like, I guess, the horizontal part of the T structure. And then the vertical would be going in depth, as you can imagine. So that could be things that are in my expertise, but I think it doesn't hurt either when you find something that's of interest and relevant to be able to dig in, even if it's something that's maybe in bio that I'm less, versed in, for example. So at least for the broad part, just kind of sticking for now to the how to stay on top of trends. That could be conferences, publications, but you also have a ton of good podcasts now, for example, that have information out there. I mean, you have a ton of different magazines, for example, you can look at, blogs, things of that nature, that people are putting out there. So I think, it's kind of a cool thing of our times is a lot of the material, you still have to go hunt for it, but it's, it's out there.
Mm-hmm. Yeah. I think I learned the most when I'm reading news articles, especially going on LinkedIn. You see a lot of interesting insights where people post clips. In this day and age, drone warfare and drone technology is all the hype and rage. So you always see a bunch of people posting clips on LinkedIn, really interesting stuff. Or, a lot of times I do try to listen to other podcasts that do release episodes, maybe bi-weekly or just an episode a week, maybe 5 or 10 minutes just talking about tech updates, like what's going on at Silicon Valley, what's Google up to, what are the folks at Tesla doing with recycling batteries, or just reading insights published by like McKinsey as well. But there is still a lot of free info that's kind of just out there that people release just out for free. I think what you were saying, what you Michael, you were bringing up earlier, but like as an individual, I have to be the one that's constantly searching for it. Frankly, I don't really do a good job, at least right now, checking like every single day. I would like to think that I do it regularly, but like I really do it I just kind of come across something that's interesting. If I'm on Spotify looking through my podcast, if I see an episode about like AI from Google, I'm like, oh, that's cool. And then so I listened to the episode for a little bit, and then I learned that for a bit. But then there's a whole part of like taking notes or just recording this info somewhere. I can't memorize all this stuff forever. I mean, if something is really impactful, I would remember it. But yeah.
I was going to say there's an interesting dimension to that too, and sorry for cutting you off there, but I was just going to bounce over what you're saying about looking on, say Spotify or others and other platforms. You kind of have not you, but I mean in general, like a tendency of algorithms to kind of reinforce what you were already looking at in the past, and sometimes that really narrows down the niche of what's being put in front of you if you're on different platforms, and so. Yeah, there is kind of that intentionality, I guess, of going out to seek things that needs to happen as opposed to maybe more passive. So that's kind of an interesting observation you had. I like that.
Yeah, just to comment on what you said, Eugene, I think the point of being active when you're looking into new topics is really important because you can kind of passively consume this content. You can listen to a podcast that's talking about new developments. But I really do think you get the most bang for your buck when you're taking notes, at least jotting things down, so that way you retain them in the future and you can go back and revisit them in a condensed format instead of having to re-listen to the podcast, which you're probably not going to do
entirety. I most of the time end up just listening to podcasts when I'm on the road, just long commutes.
It's the most convenient
It's
time.
it's just so, I want to make my time useful while I'm in the car. If I'm in a bumper to bumper, try to learn something. And there are so many times where I am listening to a podcast where I'm like, man, I wish I'm taking notes, but I'm behind the wheel, so I can't. But so exactly what you're saying, like I can't really take notes. There's an episode I really find that's interesting, maybe not necessarily about tech, but just maybe industry insights. So that I would have to go back and then, like you said, re-listen to the episodes. It's not exactly efficient, but I think it all does kind of go back to that discipline where like maybe you dedicate maybe half an hour a day, maybe when you wake up, just look for those episodes from those tech savvy channels and be like, okay, what have they released?
I mean, if you come away with only 2 or 3 key insights, just like the most important content of what was discussed, just taking 5 minutes when you reach your destination to jot it down on your phone in like the Notes app or something, I think even that can be valuable compared to just like losing those insights. Even just like a small portion of the content could probably be beneficial over time. And you still get the benefit of listening to it at a convenient time when you're not having to, have a conflict with other things that you're doing.
Right on. Yeah. Definitely.
Yeah. And great discussion, I think, what Michael mentioned, what Eugene mentioned. I think in addition to conferences and articles and journals, one source of educational content I consume a lot of personally are either documentaries or engineering videos that discuss sort of like the history of certain products or like the development cycle. I think these are really interesting because you have some very talented creators out there, especially on spaces like YouTube or that have like more scientific or engineering documentaries. And they have usually very good animations, very intuitive explanations. I think it helps to fill out kind of the top part of the T structure. You can get exposed to maybe new manufacturing processes or how problems were solved in the past.
Yeah.
And one more thing I like are videos that kind of detail someone's journey on making a technical project. So they'll sort of explain like what they're going for, what the requirements are, and they'll walk through the whole engineering process, including the pitfalls, the failures they had. Usually they don't get very deep into the math, but it's a very wonderful starting point for thinking about how you can approach different problems and what tools are available in different fields.
Yeah. I fully agree with you there and there. There's immediately a bunch of videos from like people I watch that come to mind where you're like, man, like it really goes a long way to have that mix of, audio and visual kind of explanation. But it makes me think of, we talked about kind of getting news sources, just from different areas and sort of staying on top of what's happening in the world. But what you just mentioned now made me think of, when it comes to picking and choosing what you want to implement for yourself, say as a company, for example, like, okay, you've went out and you've looked at a couple trends. Okay, now which ones do you choose to adopt, and whether it's mimicking or deciding to follow a certain market direction, for example. And to me, that's where like the interesting and the hard part kind of starts, right? Because now you got to distinguish, well, which trends are you just kind of observing? Which one do you follow? Which one do you want to discard? And I guess the way I kind of map that out in my head, it's more of a kind of like a quad chart almost of like importance and urgency. If you kind of take that as 2 variables. And so in that, say, top right corner, you're going to have things that are maybe important and urgent for the company to do in terms of, key enabling technology. Let's say it's on drones, for example. I know that could be like a new battery, for example, that you might have a certain sense of urgency and importance because now it enables twice the range, right? And it's like a game changer compared to your competitors. And so those are kind of like the easy ones where you want to focus there. And then you got those opposite where they're neither important nor urgent. And, you could probably safely disregard that. And then where it gets kind of interesting is those things that are on those diagonal terms, essentially. And the reason is because you might have things that are not urgent, but they're important. And those are things you can kind of keep on your radar and you can, kind of circle back later, take some time to learn more, go in depth, learn those pitfalls. But then there's the whole category of it's urgent but not important. And I feel like that's kind of that pitfall area where it's very tempting to get stuck on details that when you have that ability to look back, and that's where kind of the journey came in, is once you have that perspective, you kind of realize that that's sort of, I don't know what the right metaphor is, like a sand pit, quicksand, where you can get stuck for a very long time, but it didn't really add much value to that, at least scientific, engineering, and business journey as well. So I think looking at those is extremely important.
So Michael, you sort of predicted my next question there, which is, as an engineer, how do you determine what trends are worth following and what trends you should maybe put on the back burner or just keep aware of? I think you did a really good job of talking about this, but
yeah, well, thank you. Yeah, that's totally not intentional. So sorry for jumping ahead. I mean, I do want to give Eugene a chance to react to if you had to.
No, it's
first,
fine.
But
go on.
Yeah, no, but I think there's that question of which trends do you follow, and I think kind of the way I think about it is, or I guess what I would encourage our listeners and others, even ourselves as a team, to do is to kind of have that systems thinking when you look at a trend. It's very enticing to look at the shiny new object and it looks like it could solve all your problems, but you really do sort of have to pause in that process, right? And kind of ask yourselves, say you have a technology that you want to implement for your own use case in your own company, right? Maybe you're a startup and you're kind of trying to figure out what to implement first. You do want to look at the inputs that are going to be required, like what kind of knowledge are you going to need, right? If it's again, just going to take the battery example, right? Like, is there something new you're going to need to learn about that, different soldering type or different design changes that you're going to have to make with that, is there processes that you're going to have to change? So that could be the way you assemble, maybe before you could put the battery pack in first and then do a bunch of things around it. Now, maybe for different reasons, of either chemical interactions or electrostatic discharge, you might have to reverse your process. That's going to have an impact on how your operations are being run and whether you can or want to adopt a certain technology, right? Once you've looked at those inputs and sort of those processes, inputs and processes, then you do want to look at the actual output, which is what did that change yield, right? And so is it worth all that effort, right? I think it's really, you don't know until you kind of reach that ratio of what am I getting out of, if you have to completely upend whatever you're doing, organize differently, maybe it's still worth it. I mean, if you reach 10x the performance, maybe it's all worth doing, right? And so it's once you have those kind of contrasts that you're able to look at that technology and really start to parse whether it's the notion of is it interesting to follow, essentially, and then you kind of want that feedback loop as well, because in this context, when we're talking about sort of exploring a technology, you're going to have sort of that first glimpse into it, but you're most likely not an expert at that time, so you're going to have a set of assumptions that you're going to come in with, and maybe the article that got you interested in that technology, when you look a little closer, you're realizing it's not exactly the same use case, or the temperature and pressure conditions they were operating at were a bit different than what your system is doing. And it turns out that in your operating part of the envelope, well, actually the performance maybe is no better than what you were doing before. So to me, at least, like how I think about whether a technology should be adopted, you really have to look at kind of like Pareto's law almost, like what are those technologies that are going to yield 80% of the effort with 20% of the effort. But then when you kind of start digging at what that means, it's kind of that systems thinking that really helps tie it together, right? Like, how does it fit into what I'm already doing? If changes are needed, the ideal, I guess, output would be you don't have to learn anything new. You don't change your processes. You have like amazing yield or performance improvements.
Wouldn't that be great?
Yeah. And then your feedback loop is you're doing amazing. This was all the right choices. Then it's a no-brainer, of course, but it's super rare to encounter those scenarios. I mean, most likely you're going to have to pay for it, quote unquote, somewhere. And that could be just either the knowledge you need to gain, and that's time, or changing your processing, that's probably also time and money, perhaps, or just like a small improvement. But if you're in a super competitive market, I mean, maybe, I guess that notion of what is sufficient improvement, interestingly enough, is going to change pretty wildly depending on.
And even small improvements can really compound at large scales.
Yeah, absolutely. Yeah, and I know it's common, especially if you're maybe in the VC world, to talk about 4x, 10x improvement, like magnitudes of improvements, but there's a lot of industries where 5% is like an amazing, especially if you're talking engines or things of that nature, in space propulsion, for example. I mean, 5% could be a really amazing change for a spacecraft. I mean, that has huge implications to the rest of the design. So
absolutely. Yeah.
Something you bring up, Michael, there around the middle of what you're saying about the whole idea of making sure you're fitting whatever you kind of find as an interesting, putting in the right context. Because at least for me, and I'm sure for a lot of people, it's really easy to kind of come across something on the internet, whether it's technology or cool logo design. People are like, oh, that's so cool. But it's like, you guys sit down and really think, or even just like recently we were looking at different ways people format podcasts, how you start an intro and stuff like that. And I could get really carried away, be like, oh, that's so cool. And part of me is because, this is what the professionals are doing. So if I want our team to be professional, we should do something like that. But, Michael, you do a really good job on trying to rein me in and be like, sit down and think about why is what they're doing works in that given context, in that kind of market or industry. Going back to the original question you were asking about, Jonathan, like how do you pursue trends that are meaningful? It's like what graphic designers kind of say, it's like how do you identify like a trend from a fad, so to speak, where it's like fads are just things that kind of come and go in a couple of days, months, years, but they're not here to stay. Trends are usually what defines an industry moving forward. So how do you define one or the other? And I think definitely talking about what are the returns that you get, I think what you were saying before, Michael, about the amount of effort you're putting in and the amount you're getting out, is it really worth it? So really, I think it really does kind of come down to you not letting yourself get carried away with whatever sounds cool at the moment, whatever's shiny, like you two are saying, and really think about like the context, and then think about what you're getting out of it. And for us as a team, we really do have to be efficient with all that we do, not just because of the current state of the team that we're in, but just kind of maintain the integrity of how we want to do things. We want to just burn money and waste time.
Yeah. Appreciate the compliment, by the way. Thank you. No, but absolutely, context is extremely important.
Yeah. I think great answers from Michael and Eugene. I think we've done a pretty good job circling around this question. And so I wanted to pose a question related to something Eugene said earlier. So Eugene mentioned earlier that back when we were talking about what it means to stay informed on emerging technologies, about how it requires a level of individual discipline. But I also think that being an informed engineer has to do with team culture and what the company or the wider team you're working on, and how it supports its members. So I was going to ask, what can engineering teams do in order to promote continual learning and industry know-how?
Yeah, that's an awesome question, by the way, because it deals a lot with how you choose to organize and whether you can enable that learning in the first place. I do fundamentally believe you need to achieve a certain level of learning for all this to come together. You have sort of your rote memorization level, that may be your first introduction to whatever XYZ technology it is. But to really be successful at understanding all that systems thinking, what that return on investment might be, and so on, what system it takes apart on, you do need to be able to ultimately explain things simply, or learn it to a point where you can explain things simply so that you can then tie it back into the bigger picture, right? So you kind of go in depth in your learning, so then you're able to kind of almost go back up the ladder or whatever metaphorical staircase to then be able to see how it fits in that environment. And to be able to do that takes time, right? So if, at least, that's my belief, but if you're kind of not creating that space where people have time to learn, so if you're idolizing the grind, so to speak, where your team is always, nose down, working hard, I mean, that's good for maybe productivity in the short term, but you're not really giving them the time and opportunity to learn, to look at what else is out there. And I kind of think of it like an exploration algorithm, like every now and then, it's great to sort of exploit what you already know how to do, but you got to be able to look up and start exploring other parts. And again, that takes time away from that. So part of it is not necessarily, at least in how we organize as a team, not rewarding the grind, but also rewarding efficiency, because efficiency leaves that room for learning. The other part is, kind of how you reward people. If you reward people on your team that are done with work, with more work, you're not also rewarding that exploration. Whereas if you have really good contributors that do brilliant things, right? And I would include y'all in that basket. You do want to be able to reward with the opportunity for them to explore and maybe look at other works or projects that they are interested in. For one, you're fostering the natural interest of that person, but that's also where you discover those cross correlations, right? Because it's never as easy as, think of things like biomimicry. At some point, someone paused and said, hey, hang on, there's this other thing that's not really related to engineering, but we can learn from this. Or sometimes people will mix different arts with engineering. And so I think by fostering sort of that dynamic where you can let people sort of pick and choose a little bit, that's one way of kind of, leaning into that exploration algorithm, because no single one person is going to necessarily anticipate all the combinations of things that could then lead to a product. So I think enabling your team to sort of divide and conquer in that manner is really powerful. And yeah, that's something I think we should strive for.
I think even just coming down to what kind of team and company you are, where for the folks who are listening who probably understand engineering, like in a more corporate level, you have manufacturers, and then you also have like your prime contractors, for example. You have the prime contractors who compete for some sort of proposal, and they start, they have that trade space in the beginning, they're designing the system. And then at some point along the line, they realize, hey, we have an idea of what we want to make. So then they go to the manufacturers. So if you're a team in the manufacturers, you don't really have a lot of design space or kind of trade space to kind of explore. As far as I understand, please correct me if I'm wrong, but at that point you kind of have like the list of specs and things you have to create. So at that point, there really isn't that much space where you can one innovate because you're doing something on behalf of another. You have a customer that you want to satisfy, and you already have everything kind of figured out for you. If they want, I don't know, maybe a test coupon that has to be a certain size, you need to drill in at a certain point. Your CNC mills have to be drilling this line or something. Obviously you shouldn't deviate from that. So not a lot of exploring because that's not what you're being paid to do.
Yeah, no, I do agree. Yeah, sometimes it's in that example, for example, you'll have something that's very prescribed, and sometimes you do see it if you're on the prime side, or in my past, like on the JPL side, sometimes you already have a defined idea of what you want, but in some ways the manufacturer also knows what their capabilities are, and sometimes they have good recommendations, and so it's also about being able to hear them out on what they recommend, because sometimes they do know a little better, and like you'd probably be well served to actually hear that consideration, and maybe ultimately for whatever reason it doesn't play well with some other subsystem back for whatever project you're working on. But yeah, sometimes that can be a little bit constrained. If you're like in that case where it's super prescribed, sure.
And on that note, even like if stepping aside from the whole manufacturers versus primes, it's like if you're just a team, a commercial team, a private team that's not affiliated with the government, you have to solve the problems that no one really has solved before. You can't constantly be iterating on technologies that's already been hashed on for decades by other companies. So for example, Michael, you and I, we've talked a little bit about car companies, like I think it was like last week or so, but the idea is that my question before was, how do you have so many different car companies that are essentially selling the same product? How are they all making money and thriving, even if they all seem to apparently sell the same thing? But then you kind of open my eyes where it's like, it isn't all, rosy in the automobile industry, where people are really competing for that 1% differentiating factor. But at some point, everyone is converging onto like the same kind of design, same kind of system. And that's starting to happen with the launch industry as well, where you have SpaceX with its rockets, but you have Rocket Lab with its rockets, and ABL, and a lot of any rising launch vehicle startup will end up kind of creating the same kind of thing. So, and it's not that because we want, well, I guess part of it is that you want to fit in, but also kind of the physics and everything starts to settle down, so to speak. So there isn't really that much exploration that you can necessarily do. So as a team, you kind of have to also, from the very beginning, kind of pick the problems that kind of do encourage a lot of exploration, and kind of try to capitalize on trends and things that other people out in the world are doing that you can maybe tap into.
Yeah, no, I like what you're saying, and at least the way I see it, kind of tie into Jonathan's question, is that you do have in any given technology or market, like cars, for example, you end up converging together and fighting for market share, and then every now and then you will have sort of that game-changing technology. And not that long ago, it might have been EVs for the car industry, where you all of a sudden take what is fighting for market share to making it, what people call the blue ocean sort of market, where now anything's kind of fair game, right? And you have a bunch of EVs with different technical directions, just like launch vehicles eventually, and now perhaps getting quite saturated. And, eventually maybe you have another alternative technology or a game-changing improvement that comes along the way, and now all of a sudden kind of you follow this sort of cyclical pattern of you have a technology, then you kind of tend to exploit it essentially to make good products, and then you saturate that market, and then eventually you have that sort of ongoing cyclicality. And so it is kind of interesting to your point, like if you want to be able to break that mold as a company and not necessarily be just following, you do have to ask yourself what you're doing to do that, right? And so if you're going in the same direction as everyone else, by definition, it's not impossible, but unlikely you're going to break the trend, right? If you're going 180 from that, well, maybe there was a reason why everyone was going in the same direction, so maybe it's not smart, right? And so I kind of like this definition. I know we had talked about this, the three of us, quite a bit, but like I like this notion of the 90-degree turn, where you're not necessarily trying to do the opposite as everyone else, because again, maybe there's a reason why they're moving in direction, but you are trying to carve out your own path with maybe your own technological choice that you understand, that you can make sense of as part of your system, and how you integrate it. That almost would be the equivalent of kind of like how Tesla chose their electrical design for their car. They kind of broke away from the conventional system, which enabled them to implement other technologies. And that was the system they understood, they had a vision for how they were going to implement it. And that's the kind of thing I mean, for example, by that 90-degree turn, where there was a convention that was set and they decided, hey, well, we're not going to, go opposite of electricity. That would have been that 180 turn. But they're not going to lean into that convention either, which would have been going along the path. And so that might be a good sort of recent example, just to kind of stick to the car industry in this case of what carving your own path can do. And so I think especially those directions, once you've identified them, those are really worth exploring.
Absolutely. I think that's a interesting way to think about as a company, not just promoting like the learning of members by like giving them access to, like what other people are doing and like normal educational resources, but picking problems that kind of lend themselves to innovation and allow people to grow and allow the company to pursue a new direction.
Yeah.
Okay. And that will wrap it up for our question of the day. And that will allow us to go into our next segment called Thanks Mom, where we ask ChatGPT to generate 2 random topics and that we can ideate around, come up with a business or technical idea or somewhere between the two.
It's kind of scary. Sometimes we never know
what
what mom's going to say.
Alrighty, well, here goes nothing. Let's see. What'd you get, Mom? Here. Oh, okay, this one's interesting. Thunder stapler.
Thunder stapler. Oh, very nice.
I don't have a sassy comeback for this.
That immediately makes me think of like a nail gun.
That's actually the imagery I had in my Thunder stapler.
It's a very powerful stapler.
Yeah. And you just can't quite catch that thunder, and you just want.
Or it's just a normal stapler that's just like comically loud. It just does the normal job of a stapler, but every time you do it, it just has a speaker that's just super loud.
Honestly, think of loud too, because I guess they can make some noise. Thunder stapler would be an amazing like welding machine name, because that's pretty much what you're doing in a way, right? It's like mini localized thunder in those arcs, and you're stapling things together.
Well, this certainly makes me think of manufacturing technology. I'm trying to think what hasn't been done before in the category of thunder stapler. There's a number of technologies that come to mind. So,
yeah, that's an interesting one to ponder. And now I'm thinking plasmas in a very general sense too, I guess. It's welding. I think the stapler is making my mind go towards welding now. I'm trying to work my way out of it too, because I don't know, there's been quite a bit of improvement on welding, just in general, over the last decades. I don't know if there's like a niche market there to investigate, maybe on the electronics level as things get smaller and smaller. But I think Eugene's having an idea though.
No, I'll be honest. I'm struggling with this right now. I was thinking maybe there is something to welding, but in the case that seems like it's a pretty saturated market, I'm like, dang, I'm trying to think of something else now.
Now my mind's going in a very different direction of weather control technologies.
Huh.
I guess you're stapling your cumulus cloud somewhere else where you don't want it, dispersing it. Maybe you're stapling your thunder you don't want to another part of the map.
I mean, we could take this to its logical conclusion. Like, what would be the most powerful form of a stapler? I mean, there's, of course, rivet guns are akin to staplers in some ways.
Basically a rail gun.
Is there any science that shows that you can use like acoustic waves to bind stuff together? Because the way I'm thinking about this right now, you have thunder stapler. What if you thunder is sound, so not necessarily lightning, but then you staple it to weld stuff together. So I'm thinking maybe there is some sort of technology that can somehow use acoustic waves to bind stuff together. I don't know. First of all, if that's even possible, I'm leaning towards no, but people could fact check me online. But 2, what would even be an application of, for some reason, using that? You can't use it in space for sure. You can't do that. And then so it only work in places that has air or some sort of medium.
Go for a medium, yeah.
Yeah. So
I wonder if you could go for a metal as a medium too. I mean, I wasn't necessarily like pure acoustic, but I know you can have some
acoustics can certainly help with manufacturing processes. For example, like dispersing bubbles in processes with liquids.
Right.
So
I've seen it with cement.
Some uses for acoustics for sure, but I don't think you could purely use acoustics to fuse anything.
Yeah, but that's a good point on like, can you use it to keep certain debris out of welds? Is there like an acoustic method you could use to provide a cleaner weld, or at least optimize that? Maybe moving debris or air pockets or other things they could get. Yeah, that could be an interesting application. I guess it'd be like an extension to. I guess we're back to welding. It'd be like an extension ahead of it too. I mean, there is acoustic diagnostics. That's where my mind is going.
That is true.
Yeah, you could.
I don't know that you're stapling necessarily, but you're maybe listening in to figure out what is unstapling or what probably would require.
Yeah, perhaps you
some
could
duct
use
tape or stapling.
acoustic diagnostics to assess fasteners or to assess like weld joints. So it kind of combines the concept of a thunder stapler.
Yeah.
But more so, the stapling has already been done, and you're trying to assess how the degradation is going of those joints, or kind of like number of cycles remaining to failure, or maybe find cracks.
Yeah.
So,
Because vibrations can undo fasteners like screws and stuff, right?
yeah, absolutely.
Yeah. No, I think that's actually kind of interesting there. I mean, there is the field of like acoustic diagnostics like exists, but like maybe with modern advent of different technologies, if you're able to tie in machine learning maybe somehow, and you can reduce time before overhaul on certain machines, or you can, change the inspection limits on certain parts because you have a better ability to anticipate. I mean, certainly that would be a great field of application. Now, that kind of ties to the business aspect of which industries are really not using that technology on a common basis that actually you would really, make good use of that. Aviation, I think, probably tends to, I would imagine, use some form of that. Spacecraft, especially because you can't service it in person, they tend to use some of these methods. But I wonder, I think like trucks are like high vibration environments. I wonder if they kind of use those methods, or if someone could come up with some apparatus to do like some quick, non-intrusive scans of like, turn the truck on, we'll hear where it's rattling, and then we'll tell you, oh yeah, it's this part of the axle that's going to fail in 22 hours and 36 minutes if you keep going down Route 66. You could reach that level, that'd be pretty amazing. But yeah, maybe something along those lines too, like non-intrusive acoustic diagnostics for high, or an industry that where it's not commonplace, where maybe you could come in as a disruptor. That could be an interesting application.
So when I hear the word thunder stapler again, I'm trying to say those words in my head over and over again. Like, what does that make me think? What does that make me feel? And I keep thinking of impact, something that has impact. Because you have thunder, loud, but staplers, they do their job is very quick, because you need that impact to, bend the metal and just keep papers together. So I'm thinking like thunder stapler, I hear those words, and I think of impact. I'm thinking this is a completely different market. I'm thinking like a really powerful, like therapeutic gun, like those machine guns. For some reason,
perhaps not too powerful.
But maybe it could be used to, I don't know, massage people with really tight joints, or like, I don't know, or maybe you can use it for like a cow or a horse or something. I don't know.
The Kobe beef, I'm pretty sure, I don't know if it's still current or that's like an old tale or something, but I think allegedly they get massaged so that they're all relaxed, and that contributes to the tastiness of it. Maybe you can have the cow therapeutic gun if they don't. I'm assuming they must have one already. I imagine that's not a by hand process.
Could you?
I mean, I don't know. Maybe
perhaps
be surprised.
They do have.
Yeah, that's a trend.
Whose job is to give massages to cows to calm them down.
So now I'm thinking as well. You know how like blacksmiths, you have to constantly like smack the metal or something like that to strengthen the metal, especially if you're trying to make like a katana or something like that. You have to fold the metal a certain amount of times. Scientifically, they say you have to do in history, they say you have to do it like 80 times or something, but I think science proves that you only have to do it like 7 times to get like the 80-20
like a
thing.
Decreasing.
Diminishing returns.
Yeah, that's the words. My mind is not working. But so I'm thinking, what if you had some sort of machine that could expedite that kind of hammering process, like not just for like making knives or swords, but if any metals that need that kind of tempering, rapidly. Like so, I'm trying leaning into the thunder stapler. Like again, like I'm thinking of machine massage guns that be used to constantly smack metal in case you need that for any purposes.
I wonder if because you have like some industrial processes like forming and others where you'll essentially kind of have a big industrial kind of hammering process. I don't know if there'd be any merit to like kind of taking the idea that massage gun, but like localized and small, like if you can locally reinforce that region but not others, like intentional failure points, where sometimes that's a way of distributing force and an impact. If you're like in an accident or something, like you want certain things to snap preferentially because the force is going to get transferred into that weak point, as opposed to having maybe the passenger or some other critical component take the hit too. So I wonder if that would be a more effective way of like locally reinforcing sort of metal structures, but not necessarily others. Maybe there's a more, rather than just a brute force machine that just folds it and compresses it, something that's a little more like a robotic arm that can like preferentially or go a little more intricate in how it does that folding essentially.
I also think perhaps you could have some sort of tool. Having it be a thunder stapler implies to me a percussive charge, where like it operates based on like black powder or explosive force.
Yeah.
So there could perhaps be a tool that, let's say you have like two sheets of metal that are on top of each other and you want to create a joint between them.
Mm-hmm.
You could maybe do the same process that's done, for example, like with cans, where you like fold them over each other and create a airtight seam. So maybe for larger, thicker pieces of metal, the thunder stapler could be something that you place on this seam, and then it like percussively folds the seam together and like merges the two plates hermetically.
Okay, yeah.
So it would be similar to a rivet gun, but without the added mass of the rivet itself. It would be hard to undo, though.
I could see that. Yeah, certain like pinch-off systems for
Mhm.
more malleable metals like copper. Like
Exactly.
sometimes you can
Something
actually
you can cold
just pinch them
form.
off
Yeah.
to stop like a liquid flow, possibly at least minimize the gas flow. It's probably not perfectly sealed, but
Mhm.
like for liquids, maybe it's enough. Yeah, I mean, it could be pneumatic as well. Those things can be pretty loud, but yeah, no, it could be like a. I don't know how big of a market there is for copper pinch offs.
Exactly.
But yeah, no, this one's a challenging one too because it's
Yeah.
it's
It seems like a saturated market.
yeah, no, exactly. I'm thinking like all of it. It's not brand new. Like you'd probably be doing incremental improvements. Not necessarily like game changing so far. That's a challenging one.
Exactly. It seems like the thunder stapler has been a staple of modern industry for quite a while now.
Pun intended. Yeah. Turns out humans are already really good at thunder staplers. Yeah, and that's lots of good ideas. Yeah, I'm trying to think of that one that would like turn while we were talking about like blue oceans and stuff like that. Like what's that one thing you could do that
would revolutionize the concept of a thunder stapler.
Yeah, because even those acoustic diagnostic, not an entirely new concept too, but I imagine so far the most disruptive would be if you find an area where it's, because I feel people in manufacturing are already pretty on top of different processes they can use and stuff. I think perhaps in terms of market opportunity and kind of considering that aspect, like picking a field that doesn't typically do acoustics that would benefit from it too.
Try to bring thunder staplers to the masses.
Yeah, no, yeah, exactly. Yeah. I mean, I'm thinking like just from my own background, like helicopters and stuff. I mean, super vibration high environments, and they do weight and balancing for a bunch of stuff. But I mean, as far as I can tell, at least all the different operations I've seen, they don't do it acoustically. As a pilot, you hear when something is off acoustically. So I mean, clearly, if as a human you can identify it, I'm sure as a machine you can have much finer resolution. But maybe there's a market there for technicians, and yeah.
I wonder if you can design a new kind of fastener that does take advantage of like vibrations in the system to further tighten itself. So you normally how you have vibe tests to make sure that parts don't come off and stuff like that. Because usually the nature is if you have something that's tightened with like a nut and a screw, as it vibrates, everything starts to get undone because you kind of have to quote unquote like tighten them together, fuse them together. But what if you have a sort of a fastener that actually does take advantage of that vibration in a system that does do that a lot, so that it tightens itself over time with the vibrations? The system ends up getting more fused and stronger, due to the environment that it's operating in. So you turn what some people might see as a problem, you kind of lean into that, try to turn that into a strength, like an opportunity.
There might be some chemical solutions or sealants that might be able to do that. When you have a normal fastener, they're under tension trying to hold the two materials together. So as vibrations happen, like the internal forces in the fastener like want to spread out. So that's why they usually come undone. But perhaps for some sort of chemical solution, like the vibration would help harden it, or like
no, it's interesting because you have different chemicals like Loctite and others, or different compounds you can put on the nut to essentially lock it in place. But it's locking, it's not tightening. So I think that's where the thing that would be maybe different. You can lock the, say, nut and screw system in place, nut and bolt, so that it stays there, but it's not necessarily going to tighten over time too. So that'd be kind of an interesting way to tackle that too. Yeah. Although there's probably some upper limit where you don't want to think the tighten past a certain point.
Yeah, over tightening is a problem for sure. But that's very interesting ideas regarding the thunder stapler.
Yeah. So where are we landing on this thunder stapler?
Pretty saturated market.
I would say thunder staplers certainly do exist, and they're quite good at their jobs.
Yeah.
But there could be incremental improvements or other ways to take the concept. So.
Anyone listen to this, maybe look into a lightning stapler or a lightning pin or something.
Please let us know if you have a better idea for what the thunder stapler could be, or what it already is, or how it could be improved.
if anything, the listeners know what not to look into.
Yeah,
Yes,
exactly. Hopefully
exactly.
we've, sometimes knowing
Eliminated
what not to
the
do.
options.
Yep. Yeah.
Yeah, what
Okay.
not to do is still information.
And
Exactly.
so I'd like to thank you listeners for tuning into the Pample Pod, and we'll see you next week. Have a good one and take care.